Good afternoon, Internet. It's Jason here from Godlike Productions once more. Just testing out and doing the first recording on new streaming setup, so hopefully things will be a little bit more consistent from now on and hopefully make my life a little bit easier, which means I can do more of these videos. I've been in preparation of a number of new algorithms for the H9000, and unfortunately I broke something on my server at home, and I'm not at home at the moment, so I can't log in to run some demos. So I thought what I might do instead is do some VSIG programming, and I see there's a little bit more interest in people getting into VSIG a little bit more. So yeah, I thought I might do a little bit of a tutorial today. This one's going to be nice and simple. So what we're going to do is we're going to create a sample and hold LFO, because they're not available, just straight from, they're not available certainly within VSIG. So what I've got here, you can see I've got VSIG downloaded and installed, open. We've got a new patch here, and we're going to run through a few of the things that we need. So first up, we are going to need a knob to control the frequency. So I'm going to use a taper knob here. Where are we? Taper knob. So let's just throw this up here. Now, for those that aren't aware of VSIG, you've got two things down here on the left. You've got all your different DSP functions separated into different categories. We've got this module list which allows us to reorder things, and this is our main building area, and then over on the right we've got some parameters for for different parameters. So I'm going to take you through these things relatively slowly, just so you can sort of see, I guess, how I approach programming DSPs. So I've got our user interface side here. I usually start sticking them down underneath these. And we've got names for stuff. So it's a taper knob, and I'm just going to rename it as the LFO, or let's just call it LFO frequency up here. And then we've got a statement that we can put down here, and there's a little bit of a key that you need to use for this. So I'm just going to call it frequency, and then it's a number, so it's %, and then it's your total number of characters, and then your decimal after your character. So I'm going to put 3.1, and then we need to put F and then hertz. Okay, and here you can give it a name as well. Right, now for the frequency of the LFO we're using, I know that the minimum frequency is 0 and the maximum frequency is 1000 hertz, so it's quite a variable. Now I'm using a taper knob because the whole thing about around a taper knob is that you can have different precisions at the low end and the top end. Okay, so I want, let's give us 1000 steps, should be enough. And resolution I want 0.1, and let's start with a default of, I don't know, let's say 2 hertz, because that'll work at 120 BPM. And the taper, so to bring up the taper, or to work out what this means, you can go Control D, and that will bring up this help file. So and then down here, what we're going to use the square one. So lower number, so higher numbers, there'll be more spacing. So we're going to set taper here to 1. Okay, and alpha doesn't matter unless we're using concave or convex. So we could use concave and convex, and that would do a similar sort of thing. Okay. All right, so we've set our LFO frequency knob. This is going to be the control thing. It doesn't show up in the menu yet. We'll get to the user interface part later. Now what we need is we need an LFO. So if we go down into oscillators, this is where the LFOs live, and we've got a few candidates here. So let's just have a look at the help files again. So this is LFO, and it can go from -1000 to 1000 hertz, and we've got these different shapes here. But what we're going to make is a sample and hold, and the way that we're going to do this is we're going to trigger it from a square wave, and we're going to use a bipolar. So we could use LFO, we could use LFO2. So LFO2 is retriggerable, so it's got a trigger input on it. And then we've also got these other ones. So this is a retriggerable, another retriggerable LFO. It's got a different list of waveforms, and it's also got a slew, which can be useful, and it's also got a phase. You can change phase on it. And then we've got this syncable LFO, and this is good if you've got a number of LFOs that you want to do different bits and pieces of, and it's, again, it's quite similar. So for this one here, let's just use the RLFO, a retriggerable LFO. Not that we're going to re-trigger it in this instance, but it's going to be useful later on. All right, so what we've got here, we can see that we've got a number of different options here. So what we want to do is, this is frequency, so we want to wire this into the frequency of the LFO. Okay, now to make a sample and hold, what we need to do is that we need to trigger and we need to sample some random noise. All right, so to do this, we're going to use this, and we're going to make a square wave of this. So let's just bring up that help file again. Let's have a look at the waveforms. So we've got, they're enumerated as sine, which is going to be 0, triangle's 1, square is 2. So let's get a control. I think it's control maths. We want a C constant, and I always put my constants up here. Okay, and I call them like C constant, and then I actually give them the number. So this one here is going to be 2, and call this one 2, so that way I'll always know which one number 2 is, and this is going to generate our square wave. So let's wire it into the waveform just here. Duty cycle is at 0.5 already. The polarity of 1, I think that means that it's bipolar, which is what we want. Not yet. So 0 for the range 0, 1, and 1 for the range -1 to 1. So that still works, and the trigger slew is a fraction of the LFO period. So that's how long between that just, it's sort of like for re-triggering, so we don't, yeah, it just makes sure that's not quite instantaneous. All right, so what we need now, so we've got, this is an RF, this is an LFO, and let's just call this LFO square so that we know what it is. And then what we want to do is we want to use a, I think it's a miscellaneous one called Oneshot. All right, so we're just going to put this after at LFO. So just another little note here. Blue means it's control signals, and green means that it is audio signals. Okay, so this is generating an audio signal LFO. All right, so let's just bring up the help files for the Oneshot, and let's just see what it does. So the Oneshot is a triggered timer. When it transitions from low to high, so when the square wave goes from -1 back up to 1, it will output for a select period of time. So what we want for the sample and hold is that we really want just an impulse control, and there is an impulse LFO, so we could have done it with that, but we're just going to do it with this square wave. So it's going to stay high for a time period, and then it's going to drop back to low again. So it's really just, it basically just makes an impulse when it gets triggered. So let's just wire this up into here. So the time, where are we? So we're going to, we've already got these, a time of 1 and time of 0.5. What I tend to like to do though is for consistency, I generally like to make constants for these, because sometimes the constants don't. So sometimes typing a value into some of the blocks, into here, for example, into here. So sometimes if you type the number into here, it doesn't work. Generally the ones that have already got them in by default will work, but just for consistency, I like to wire these in. So we have time of 1 and a threshold of 0.5. So we need a constant of 0.5. So 0-5, you can't put a decimal point up there. 0.5, and this is a constant of 1. So let's label this one 1 and put 1 in here. Okay, and I've got these in order across the top. All right, so I want the into here, I want the 1 to go into the top one. Okay, so wire this number 1 into the top, and I'm going to wire number 0.5 down into here. Okay, so we've got a one-shot that can now trigger our sample and hold. So the sample and hold is also in here. So I'm going to put a sample and hold here. And so what this does, we can see what the inputs are. So we have an input and we have the new sample. So the new sample is going to get triggered by this input. And the other thing that we need is we need noise. So we're going to bring up this noise oscillator, which just generates noise, and we're going to wire that into the input of this. Okay, so essentially we now have a sample and hold with a frequency control, and it comes out of this sample and hold. Now this is an audio frequency. If we want to make this as a controller, we can stick a bridge in here so we can get audio to controller. So this is a filtered version of it, which I generally find is the best. And out here we now have a sample and hold sample and hold LFO is going to come out of here at this frequency. Okay, so we need a few other things just to tidy all of this up. So we need to go into the interface, and what we need is that we need a menu page. So put the menu page over here. So this menu page is what we're going to see on the front page of the H9000. Okay, so we need the number of subs in it. So we've only got one control in here, so let's just put 1. And this taper knob is what's going to drive that one there. We haven't got any inputs here, but we could, for example, we could just put a oscillator in here. So let's just throw an oscillator up here. Okay, we've got the frequency of 1000 Hertz and a mod amount of 1000 Hertz. And let's just see what our waveforms are. Sine is probably going to be a bit boring, so let's do a triangle wave at 1. So we've already got the 1 constant, so let's put that into the wave. And what we can now do is that we've got a mod amount here, so we can take this sample and hold output, pipe it into the mod amount, or the mod modulation, and let's just put a gain control so we don't blow our ears out. So we can so I just want to gain. Alright, so we have a gain control here. And what we can do is we can just wire that also into this menu page. So let's just make another output here. We can, the gain control's got its own object here, so we can just wire that directly into this menu page and it's going to show up, so it'll have a gain control on it. We don't need to build one, otherwise we could make our own knob and wire that into the gain control, but this does the same thing. Okay, so what this will do is that this, whatever frequency we dial up, this will modulate the frequency of our oscillator. You could, if you turn this up really quickly, you could make a crude type of FM oscillator, because it's, you know, certainly at audio frequencies. The next thing that we need to do before this is all finished is that we need to put all of these in the right order. So generally the way that we do this is we want to get rid of all these orange dots. So you can see these numbers down the bottom. What should happen is that they should flow from low numbers to high numbers, and sometimes this doesn't happen in feedback, but you can see that we've got a number 8 feeding a number 7. So there's a couple of ways that we can do this. The first way is you just hold down control and you go up and down, and you can put these, I generally put my constants first, or we can just drag them in here. Oops. And then that one there. Okay, next we have them feeding into the LFO. The frequency is feeding into that, that's good. We go to Oneshot, we need the noise up before the sample and hold. Right, so the noise now, sample and hold. We've got your filter here, we've got our oscillator, we've got our gain, we've got the menu page though, so this menu page is at the wrong spot, so let's bring this down to the bottom. Okay, and basically there we have a simple LFO oscillator. As I said, I currently don't have my H9000 connected, but if you want to, so first of all we want to save this, so let's just go save as. Yeah, get a little thing up, so let's just bring in a, go up, new folder, this is a S and H LFO. Put this into here, and we can just call this S and H LFO, and I'll call it Rev A. It's the first revision. Press save, and then if you want to upload it, you just press this little cloud button where it got it, and you can. So we'll just go through here. This is where you can give it a name. Up here, so you can call it something different to what it defaults to what your file name is, but you can give it a name of anything you like. Right. Now this first one, FX1 slot 1, that will put it into, it won't actually save it onto your H9000. What it will do is put it into the first block of the first chain, and that's where it'll live, so that's nice and easy. Usually you put it in the next empty algorithm location, or if you have a particular location you want to put it, you can tick this and actually type the name in. You can go up to 101.99 is the highest you can currently do with VSIG. One note on this though, if you have a algorithm loaded into an FX chain and you try and upload over the top of it while it's being used by one of the processors, you may crash something. So I recommend that you make sure that you don't have, if you're going to overwrite, don't have the algorithm selected in a FX algorithm. But your next empty slot, and then you can go send, and it will send it to your H9000, then you can select it from emote or from the front panel. Okay, I hope that's, you know, provide a little example. This is one way that we can do a sample and hold. The other way, while we're talking about it, let's just have a look at this impulse. All right, so we have this is the impulse here, which works. Let's just bring this up. So this will just create a pulse train of pulses. So you could use this directly instead of this LFO square and this Oneshot. What you could do is you could wire this directly into this sample and hold, and then you could use your knob to control the frequency. Same sort of thing like this. That would do the same sort of thing, but I just did want to go through, you know, go through this Oneshot and how to turn a square into an impulse, but there is an impulse here. There's also a control impulses, which is at the control frequency rather than at the audio, audio frequency. Okay, I hope this has been helpful to you all. I'm going to sign off now. Thanks again for joining me. If you like what I do, please consider buying me a coffee at the link down below at buymeacoffee.com/godlikeprod. And yeah, I'll see you around next time. I'll have some more algorithms and a few more VSIG tutorials coming your way. If you have anything in particular that you'd like to see, please let me know, either on the Eventide forums or on my website, contact me, or at Buy Me a Coffee. I do check all of those quite often, and yeah, if you have requests, let me know and I'll take you through it. I will upload this template up to for my Buy Me a Coffee subscribers, so they can get that for free. For you guys that are not yet subscribers, yeah, a little bit more learning for you. You can work your way through it and build it. It's not particularly difficult, but yeah, if you would like to get hold of this, yeah, consider subscribing and get lots of free goodies. Thanks, guys. I'll see you all later next time.